Okay, I saw this question in the homework and I would like to explain it in further detail. So you get this trig identity, and first thing that you see you have to look for is factors. So what can you factor here? Well, from this you can tell that it's a difference of squares. X squared subtract y squared. So you can expand this and you would get and you also have to factor out the cos in the denominator. And you get this. And clearly you can tell that these two cancel out. Cos theta plus sine theta multiplied by cos theta subtract sine theta. Cos theta multiplied by cos theta plus sine theta. These are all multiplications. So you can just cancel this out and cancel this out. If they're not multiplication, then you can't. It's just a rule. So then you end up with this. And from here you may think that you're just lost and you have absolutely nothing that you can do. But you just have to intuitively think here. What can you do to this fraction to split it up into two? You have to also return back to the original equation, which is 1 subtract tan theta. How can you reduce this into two? How can you expand this into two numbers, basically, two whatever. And how you do this is look at the sign within the cos theta subtract sine theta, and you remember your fraction rules. It's basically cos divided by cos subtract sine theta divided by cos theta. Okay, so yeah, back to what I was saying. You basically have to expand this into two separate variables. So how you do this is that you just got to remember your division rules and fractional rules. So if you had 1 over x plus 1 over x, this would equal 2 over x. And it's also true that 1 plus 1 divided by x equals 2 over x. Therefore, you can split up the 1x and the other 1x into 2. See how I can split this into here and then this into here? Same thing, first equation. All you gotta do is just split this up and you get this. And this equals cos theta divided by cos theta is 1, and subtract sine theta divided by cos theta is a trig identity, or just look back to the original equation, 1 subtract tan theta. Okay, let's resume to the next question. Tan squared x, hold on, I'm going to make this more clear. Tan squared x subtract sine squared x equals sine squared multiplied by tan squared. Okay, so to prove this trig identity, we have to first look at what we can we expand. So here we see that sine squared x multiplied by tan x. You can expand this to sine squared x divided by cos x, but it gives you sine squared x that gives you sine. I don't even know what's that called, quartic? I don't even know what that will be called, but we do not want this. It's just makes it a little bit more complicated. Let's keep things to squared. So here tan squared x subtract sine squared x, so you can see that you can expand this basically into sine squared x divided by cos squared x. Looks something like this. Subtract sine squared x. Okay, and this is only for the left side, and this is the right side. Just gotta rewrite this because I just forgot about it. Sorry about the previous one. Just remember to have the left side and right side stated. Okay, so here you can't quite do anything yet, but just go back to your quick tips that Mrs. Colterman taught us, and one of them was factor. So you can literally factor this. Sine squared x multiplied by 1 over cos squared x, subtract 1. See? You can factor this. Pretty easy too. And from this equation, let's go back to the original one and look at right side. Right side equals sine squared x plus tan squared x. What does this look like? Sine squared x multiplied by whatever this is. Because we ought to turn this into tan squared x. Mrs. Colterman will never give us a Pythagorean. Wait, no, not Pythagorean. She will never give us a trig identity that's impossible to solve, according to her. So we just got to assume that this equals tan squared x and go based off of our perception of the question. So let's do 1 over cos squared x, subtract cos squared x divided by cos squared x, and let's subtract this, and you get 1 subtract cos squared x divided by cos squared x. Looks something like this, and let's not have an equal sign there because I don't like how I put an equal sign there. Sorry about that. Just have it. And then this would equal, and if you just look at this closely, you can tell that you can just convert this to sine squared x because of the Pythagorean identity. Pi identity. Wait, identity? Python identity? Never mind, I don't even know. Okay, so this would equal tan squared x. And your final equation or final identity will be sine squared x multiplied by tan squared x. Yeah, that's basically it.